In the today's class, I am going to continue with the conversion of NFA with epsilon moves to without epsilon moves. Okay, how we are going to take NFA with epsilon moves and convert that into without epsilon moves. That's what I am going to discuss in the today's session. So before going to the conversion of NFA with epsilon to without epsilon, so here construct an NFA for a language over an alphabet 0, 1, 2, in which every string contains any number of zeros followed by any number of ones and followed by any number of twos. Okay, so that's what the question I am going to have now. So for that, see how we are going to get. What is the question I have given? Construct an NFA with any number of zeros followed by any number of ones followed by any number of twos. Okay, so you can have any number of zeros here. You can have any number of ones here. You can have any number of twos here. But here what you are going to have in between, if you want to go from one state to another state, what is that you are going to have? Nothing. Input is nothing here. So if you want to move from one state to another state without taking any input symbol, then what is the input you are going to take is epsilon. Okay. So what is that you are going to give is significance of the epsilon. So when there is a requirement of moving from one state to another state without reading input symbol, then specify the transition with the epsilon. So if you want to move from one state to another state without taking any input symbol, then what we are going to give as epsilon we are going to give here. So in the NFA, we are going to have the epsilon transitions. So what we are going to do? Epsilon transitions with NFA. We are going to convert that into NFA without epsilon transitions. Okay, so that is, I'm taking this particular example here for that. So see here, any number of zeros, any number of ones, any number of twos. What is the question? Previously, I have taken the same example I have taken in here also. So that is any number of zeros followed by any number of ones followed by any number of twos. So that means, see here, if you want to go from A to B, so what is the input you are going to give? Nothing. What is there? Nothing here. So I have given it as epsilon. Okay. So now I want this particular NFA with epsilon to without epsilon. So if in the exam, if they ask you that NFA with epsilon to NFA without epsilon or NFA with epsilon to DFA, so what you have to do is, first you have to convert NFA with epsilon to without epsilon. And after that, NFA without epsilon to DFA. You have to convert that. Okay. See here. So what is the transition diagram we are having for the NFA with epsilon? See, A on 0. What is the input you are giving? A on 0. What is the output you are going to get? On A only. If you give A on 0, it is going to A. So, and after that, A on 1 is going to where? Null state. Nothing is there here. A on 2 is going to where? Null state. A on epsilon also you are going to take here. So, A on epsilon is going to B state. Okay. And again, B on 0 is going to where? We don't know. It is a null state. B on 1 is going to where? B. B on 2 is going to where? Null state. B on epsilon is going to where? C. C on 0 is going to where? Null state. C on 1 is going to where? Null state. C on 2 is going to where? C. And C on epsilon is going to where? Null state. So here what we are going to do is, we are going to calculate the epsilon closures. We are going to calculate the epsilon closures here. So that means, see, epsilon closure of A means by giving the input as epsilon, where it is going to reach. So if you give the input as epsilon to A, it can reach to A. Okay. and also it can reach to B, also it can reach to C. And calculate the epsilon closure of B. So if you give the input as epsilon to B, it can reach to B and it can reach to C. If calculate the epsilon closure of C, what is that? It can go to the C only. It can go to the C only here. Okay. So epsilon closure means the set of states reachable from Q. Epsilon closure of Q means what here is the set of states reachable from Q to epsilon transitions alone here. Okay. So see here. Now what I have to do is I have to calculate. I have to give the NFA without epsilon moves. For that, what I have to do is I have to get the transition table for that. A on 0. So I have to do this. This is the formula for calculating the epsilon closures. So epsilon closure of A on 0. What is epsilon closure of A here? Already I have calculated here. That is A, B, C. So that's what we are going to do. And if it is A, B, C, comma 0, that is nothing but A, comma 0, union, B, comma 0, union, C, comma 0. So that's what we are going to do. A comma 0, B comma 0 and C comma 0. What is there in A comma 0? If you give the input as A, if you give the input as 0 to A, what is that you are going to get? A. So that's what we are going to write here. A union, B on 0 is pi, C on 0 is pi. So A union, pi. So that is nothing but A here. So that is epsilon closure of A is nothing but A, B, C. So that's what we have calculated now. So that is the transition table for NFA without epsilon moves. So I have given it as a cap here. Okay. Delta and cap I have given. That is nothing but NFA without epsilon moves. And again I have to calculate for A on 1 also. Okay. So the same procedure will be repeated for A on 1 also. Epsilon closure of A comma 1. So epsilon closure of A means ABC comma 1. So that is ABC comma 1 is nothing but A comma 1 union B comma 1 union C comma 1. So that is nothing but A on 1. If you give the input as 1 to A, so what is that you are going to get? Null state. If you give the input B, so for B, if you give the input as 1, so what is that you are going to, B on 1 is 1 and C on 1 is 5. So epsilon closure of B you are going to get. Pi union, B union, pi is nothing but B. So what is epsilon closure of B? B comma C. And coming to the A comma 2. So I have to calculate A comma 2 also where it is going to have. So epsilon closure of A comma 2. So epsilon closure of A is already we have calculated first. So what is that? A, B, C. So A comma 2, B comma 2 and C comma 2. So here A on 2. If you give the input as 2 to A, what is that you are going to get? Pi. If you give the input as 2 to B, what is that you are going to get? Pi. If you give the input as 2 to C, what is that you are going to get? C. So the epsilon closure of C is C here. Now B on 0. So epsilon closure of B comma 0. So epsilon closure of B is nothing but B comma C here. So B on 0 union C on 0. So that is B on 0 is 5 union C on 0 is also 5. So the epsilon closure of 5 is nothing but 5 here. Okay. Coming to B on 1. So that is epsilon closure of B. Epsilon closure of B is nothing but B comma C. So B on 1 union C on 1. So what is that B on 1? We are already having the transition table above, no? So you have to see that. So that is B on 1 is nothing but B. And C on 1 is nothing but again null state. So epsilon closure of B is nothing but here B comma C. And coming to the B comma 2. So epsilon closure of B comma 2. Epsilon closure of B is nothing but B comma C comma 2. So that is B B comma 2 union C comma 2. B on 2 is pi again and union C comma 2 is nothing but C. So that is C. So epsilon closure of C comma 0. Epsilon closure of C is nothing but C comma 0. So epsilon closure of pi here. So that is equal to pi. And again, C on 1 is epsilon closure of C comma 1. So C comma 1 is nothing but again pi here. So that will be pi. And again, epsilon closure of C comma 2. So C comma 2. C on 2 is C. Epsilon closure of C is C again. So this is what the transition table we have here. Okay. So now what is that you are going to get? A on 0 is going to where? A on 0 is going to where? A, B, and also C. Okay. A on 1 is going to where? A on 1 is going to B and also C. Okay. So that's what I have written here. And then again, A on 2 is going to where? C. So that's what we have written here, C. And again, B on 0 is going to where? Null. So we are not going to give anything. So again, B on 1 is going to where? B itself and also go to C. And B on 2 is going to where? C. Okay, I have given it as B on 2 to C. And again, C on 0 is going to where? Pi. And C on 1 is going to where? Pi. So we have not written anything here. And then C on 2 is going to where? C. Okay, I have given it as self-loop here. So, is there any epsilon transitions now? No. So we have removed all the epsilon transitions. That's what we are, that's how we are going to convert NFA with epsilon to NFA without epsilon. So if you get a question as directly NFA with epsilon to DFA, then what you are going to do is, see here, NFA with epsilon to NFA without epsilon. First, you are going to convert that NFA with epsilon to NFA without epsilon. And after that, you are going to convert NFA without epsilon to DFA. So, that is how we are going to convert from NFA with epsilon to without epsilon. So this is also one more example. Just I will tell you the epsilon closures of this particular example here. So this, in this also see, we'll be having the epsilon transitions only in this. So what we have to do, we have to convert that into NFA without epsilon moves. So see here what we are going to do. Epsilon closure of A. So this is the transition table we are having here. And how to calculate the epsilon closures of A. So see here, epsilon closures of A means it is going to A. Compulsory it will go to that particular state. So it is going to A. And from A, where it is going? B. From B, where it is going? By giving epsilon as input, nothing. Okay. So we will give it as A comma B. And epsilon closure of B means compulsory we'll get B. And from B, is there any other state it is going here with by giving an input as epsilon? No. So that means only B. And epsilon closure of C. See here, compulsory C we will get. And after that, what we are going to have? By giving the input as epsilon, it is going to be. So, epsilon closure of C is C comma B. And after that, epsilon closure of D is compulsory D we will get. And after that, from D where you are going? C. And from C where you are going? B. So, we will get as D, C and B. Okay. So that is a very, very important to calculate the epsilon closures. Based on your epsilon closures only, you'll get the output here. That may be the epsilon, the NFA without epsilon modes. Okay. So main part is calculation of these epsilon closures. Epsilon closures calculation is nothing but from that particular state by giving the input as epsilon, where it is going. Okay. Whether it is going to next state or it is not going to anywhere. So if it is not going to anywhere, only what is the state you are taking, that particular state will be the output here. So suppose epsilon closure of A is equal to epsilon closure of A is equal to A comma B I have taken. So that means compulsory A should be there. From A, where it is going, by giving an input as epsilon, it is going to B. So that's what I am going to tell you now. Okay, so that is about the NFA with epsilon to NFA without epsilon. Conversion of NFA with epsilon modes to conversion of NFA without epsilon modes. That's all about today's session.